All right, so that brings me to private blockchains, which is purportedly one of the alternatives that one can have in addition to or instead of a public blockchain. So first, to get the terminology right here. So public blockchain essentially is what we think of Bitcoin and Ethereum. There are no restrictions on who can read the data, although it may be encrypted. There is no restrictions on who can submit transactions for inclusion in the blockchain. And in principle, any kind of, you can also become a miner and participate in the maintenance of the blockchain. Now, private blockchain is the opposite. There, it is organized by a small group, could be a small or large group of people, but it's certainly not fully decentralized. It is usually operated by, it could be government, it could be by a firm. Then there are differences in the permission status. So there are permissionless and permission blockchains. Public blockchains, by definition, are permissionless, so there's no restriction on identities of who can use them. Although, and this is important, you can use a public blockchain and put restrictions on it, and we're going to come to some examples later. Then there are permission blockchains, and private blockchains commonly tend to be those where there is some limitations of who can access it and who can use it. And when I say limitation, it means really that the operator of this network or of the blockchain has some choice as to whether or not to let particular people in. However, one can build a private blockchain in such a way that it is permissionless. So it's not private, and permissionless is not a contradiction. What I want to do and what follows, I want to go through essentially three main developments of private blockchain. I'm going to talk about the Ethereum Enterprise Alliance, I'm going to talk about HyperLedger, and I'm going to talk about the R3 consortium and their Corda ledger. So first of all, but let's just talk about why do we care? Why should we have a private blockchain? What are the possible advantages of this? Well, most of them, if you think of blockchain, the native application of blockchain are in finance, and in finance are regulations, very important regulations that are not easily circumvented. So the two ones that come to mind first are know your client and anti-money laundering. So know your client essentially means that a private operator needs to know who is using their product, who is using their chain. The idea here is that you want to restrict investments to investors for whom it is suitable. And you also want to make sure that you do not have a client who could participate in anti-money laundering. And that's the second point. Anti-money laundering is a big concern. If you have ever watched Netflix and the Narcos series, that criminals all over the world have a hard time converting their illegally earned money into properly earned money, and so anti-money laundering is money laundering is a way for them to do it, and it's an obligation of banks and financial institutions in general to take measures to prevent money laundering. Another advantage of a private blockchain is that there's no need for cryptocurrency, whereas public blockchains such as Bitcoin and Ethereum need cryptocurrency that is built in order to be operating, and because they need some form of reward system that is in there. With a private blockchain, essentially you can do the operation of the network for free, or fold the fees that you charge into other services, into the price of other services. Private blockchain also tend to be easier scalable. There's usually no proof of work involved, and that makes it relatively straightforward to increase the throughput as much as you want. And the argument that's often put forward is that there's higher data protection, so it's higher control over what information is shared, who in an organization gets to see data, and how are the interactions organized. But let's discuss it a little bit here in the classroom, which obviously I'm not going to do on this YouTube video. So let's first talk about the Ethereum Enterprise Alliance. Now, the idea is common to most of the implementation that I have read about. The idea here is that you use and build blockchains or applications on top of the Ethereum blockchain. You use open source tools, and thereby have the ability to access a much larger group of developers and make people want to contribute to an ecosystem. The advantage of that is you preserve interoperability of systems, because it is open source. Many parties can see what is happening, and that makes it just easier for applications and for firms to interact. Also, it has the direct link with the Ethereum network, which is widely used and is quite a clever idea. So the idea is it could very well be the best of both worlds. So now let's talk briefly about the Ethereum Enterprise Alliance. That's essentially a group at the moment of about 150 companies that are members. They have collected so far over 400 million in VC funding, and there have been issuances of about 900 million US dollars worth of tokens since November 2016. And if you look at this list, many major firms are part of this consortium, such as British Petrol, Accenture, JP Morgan, and so on and so forth. So let's look at a few implementations of this. Let's start with the Raiden Network. Now, the idea of the Raiden Network is that it is an off-scale, it's a scaling solution. Essentially, it's built on top of the Ethereum blockchain. And what it allows is to do the standard token transfers. We're going to talk about the details of the tokens later, but just think about it as a coin or token that you can change. Now, there is no need here, however, for a global consensus. How is this being done? Well, basically, the idea is that parties interact with one another. They double sign, as I understand, their transactions, and then finally, when they have a final transaction, they will settle on the blockchain. Now, the way it usually works is that two parties take a contract, they sign a contract, and they put money into a contract, and then they interact with one another by sharing messages and sending messages back and forth. And when they're done interacting, they are just settling the final trade on the Ethereum blockchain. So in some form, what this is very similar to the side channels that I have discussed earlier already, in the sense of that this basically is bilateral agreements or bilateral trades. And of course, the idea of this network is that these escrow accounts that two parties use among one another can be expanded so that multiple parties can interact with one another through this network. And here, if I may summarize, the main part is that both sides sign transactions as similar to the Bitcoin's Lightning Network, so that there is always a hash-secured record of interactions. And so if ever there is any dispute, it can be brought to the Ethereum blockchain, and then it goes back into an automated smart contract, and essentially the network as a whole would then settle any dispute directly by its processing power. The next example is Quorum, which was initiated by JP Morgan. The idea of the Quorum network is that it builds on top of the Ethereum blockchain. It builds a private blockchain on top of the Ethereum blockchain where interactions are restricted to known nodes. So if you remember the first point I brought up earlier of the concerns about blockchains, that it's not enterprise ready, the nodes are not known. All of these nodes in this network would be known. The interactions between different parties are private. They are trustless in the way this network is being organized. And the important part is that there is a privacy layer for the smart contract. So the idea being that these contracts and the interaction of these contracts is based on zero-knowledge technology. So again, just like in the Raiden network, you will have hashes of encrypted contracts will be stored on the public chain, and hashes of transactions will be recorded and finally settled on the public blockchain. So the key feature is here to the very clever usage of the zero-knowledge proofs. So this is just a fancy slide, which essentially shows the idea of zero knowledge as I used before, as I described it before. So here we go.
Let me now briefly talk about the ION network. The idea of this one is it's built on the promise that in the future there may be many blockchains. In particular, enterprises will probably operate different blockchains, maybe different parts of their firm, simply because it may lend itself to it when you have different countries, different applications when two firms merge. There's many reasons why firms may run separate blockchains. And in particular, mined blockchains such as Ethereum may not be adequate and may not be suitable for many of the business applications. And so what the Ion Network aims to do is to build a bridge to set a standard and then build a connection between the various different blockchains. And the idea is, just like Ethereum, they want to have a high-performance virtual machine for smart contract executions, a scalable database. And then what they want is that, you can build your own databases or blockchains and that you can have them communicate with one another. So the general idea of how they operate is as follows. There is a network, consists of multiple different databases or multiple different blockchains, and they want to be the connector between these two. So between each network, there is a bridge. So this is a transaction bridge, which allows the sending of backwards and forwards of messages, value, whatever is necessary for that. And these transaction bridges are supported by validators. And what these validators do is they essentially validate the transactions going in and out of a network. And the votes that they do then get stored on the Ethereum blockchain as a permanent record of behavior. Now, the idea of these validators is they work essentially in a similar manner as representatives in a democracy. So anybody can vote for other validators, and they can also be voted to become a validator. And when you vote, you have to back it with a stake. Now, the way it works is that your validator, if so chosen, would then validate the blockchain or validate transactions. And there will be a reward coming from tokens for the network bridges. And those flows will then go back to the backers of the voter, of the validator. And the consensus protocol that they are engaged in is the so-called proof of intelligence. Now, how does that work? Well, this is it's a little bit messy. I'm not entirely sure because I'm not an expert on this, but my understanding is as follows, is that the network participants are required to train a neural network such that when you have an output, it's approximately the same as the proposed ground truth. So for instance, when you have a set of previous blocks and you have the hashes for those, and you find the hash of the current block, then there's a relation between the two. And that is then expressed by the output. And the parameters of the trained neural network will then serve as a proof that a computation in fact took place. So that's the proof of intelligence. Now let's quickly talk about HyperLedger Sawtooth, or let's not talk about it. All right. Now let's talk next about HyperLedger. Now HyperLedger is, first let's just talk about HyperLedger itself. HyperLedger is not a blockchain. It's also not a company. It's not a cryptocurrency. What it is a project which comes from the Linux, or was initiated by the Linux Foundation, and it is open source. Now, there are multiple different subtribes, if you want, of HyperLedger. The first one I want to talk about is something referred to as Sawtooth. Now, Sawtooth is a blockchain suite, so that's a set of tools which have been proposed by Intel. And what they use is a consensus protocol to update the network, which is called the proof of elapsed time. I'll come to that in a second. The whole segment is written in Python. So, for those of you who took the Python course, you'll be very happy to hear this. And this protocol allows both permissioned and permissionless applications. Now let's talk briefly about what is the proof of elapsed time. So what the system is essentially, it's based on a particular feature of new CPUs, and most of them are Intel built. And so the idea is that you, as in any blockchain, there is a random mechanism by which a particular entity is picked and chosen to become the validator for a block, or to be able to add a block to the blockchain. Now, the way it works here is so in the proof of work protocol is basically you have to solve this puzzle, you have to expense energy, and then that increases the chances of being able to write to the network. What you have to do here is you basically have to send a secure instruction to send to the CPU. For that, you request the wait time. This requested wait time is reported, and then the validator out of a set of possible validators that has the shortest wait time will be elected as the leader. And so this whole process of getting this wait time is essentially a random process. So it works in a similar manner. Right now, the architecture is a little similar to what we have seen in other applications, but needless to say, this is much more database management oriented. So here's my very, very simplistic view of how this works. The idea of what they want to do is they want to isolate consensus from the transaction validation, right? So the way it works is transactions are sent to validators. They check whether or not the transaction is valid. So this is again based on the same idea as in public blockchain with public-private keys. Then they take the transaction and they form batches. And these batches are then sent to block publishers. And what these publishers do is they would allow the winners of the proof of elapsed time to validate the blocks. And then there's a chain controller, and what that chain controller does is he or she or it updates the head of the chain to ensure that at any given point, information about the current state of the blockchain is disseminated in the network. So now let's talk about HyperLedger Fabric. This was developed by IBM. It's implemented in the language Go, and it has its own smart contract language, which is called chain code. Now, the basic idea is that you have two-party interactions. So the two parties interact with one another. They write contracts, they write transactions, and once they're ready to publish what they need to publish and what they feel that an outside party needs to have, they publish only what's necessary to the public chain. So what that does, of course, it saves the processing cost because only the relevant data is committed to the public chain. It increases speed and privacy. And it's commonly understood that this is a permission system. So in this system, there are the following key roles. There are the consenters. So what they do is they order the already validated transactions. And then there's the endorsers. And what they do is they validate, build, and propagate transactions in chain code. And then we also have committers. These are entities that commit data to the chain. So let's take an example here. This is actually from a video that HyperLedger uses on its website. You see the two green parties. You see the market and you see a radish farm. This is a radish farm in Chile that makes a deal with a market, and they make a private deal in which they say they give the market a particular discount. Now, in this case, what they want is they don't want all of these different parties that could be part of the interaction. They don't want them to all know what kind of special deals they have. So this is why this little piece here is in the middle is locked, and you have all of these other different marketplaces. The radish farm doesn't want to know that they sold maybe at a discount to this one market, and they don't want to know that the customers know what they sold for. Now, how does this work? Well, the market would go to an application service and a membership service and then validate that the radish farm is the radish farm. They exchange the data that they need to have, and then this data gets committed to the blockchain. So it gets sent to validators, and then it gets committed to the chain, so that when at any point later in time, other parties such as shippers, such as customs, such as regulators need to know information that is specific for them, it can be extracted from this chain. Now, finally, let me talk about the R3 consortium. The R3 consortium is a consortium built by many of the world's largest banks especially for several, maybe 1 or 2 years. Almost every major bank in the world was part of this consortium. And what their idea is they wanted to explore whether there's a solution with blockchain technology that they can employ for their business processes. Now, my understanding is that many banks signed off from this consortium just to figure out what's going on, just to listen in what other people were talking about. And at the end of the day, kudos to them. What they designed was they did develop a distributed ledger system that is basically based on the consensus among the major financial institutions. Or you can also think about it as this is a blockchain decided by committee. The idea is similar as in others. What you do is you keep transaction details only locally. You rely on direct interactions between parties with distinct record keeping. And as you can see, you have these two people that want to interact. There may be situations when you need to involve a regulator. There may be situations when you need to involve a court. But generally speaking, you want the information between these two parties to be private. If there is ever a dispute between these two parties, then there are so-called digital notaries that would settle the dispute. Now, my personal take is that this entire world of that R3 has created, or this distributed ledger, is essentially, first of all, it's not even a ledger in the sense of that in a ledger, in my understanding, is you append data. That's not really the case here. Essentially, what they have done is they've tried to take current business processes and current business logic and try to squeeze it into a new technology, a new database system, which they refer to as a distributed ledger.